Okay, the next, I started a little bit late, but this is actually the continuation of worksheet 13. On number 17, there is a little T-chart. That's what I call these. I usually don't make the whole box thing. But this is only a sampling of what you might plug in and plot. Okay? So it doesn't mean that these are the only numbers you could plug in. So please understand that that's not what this is indicating. It's just giving us a suggestion of some numbers to plug in. So if we substitute in -1 and do put in that for x, we will find out the y value that goes with it. So I'm going to do y would equal then -1 squared minus 1. You're just substituting it in. -1 squared is 1. 1 minus 1 is 0. I tend to do them in my head if they're not very big numbers. What if you stuck in 0 into the equation? Then you'd have 0 squared minus 1, which would be -1. And if you put in 1 squared minus 1, which would be 0. Now, as I said, these are not the only values you could substitute in for x. So I'm going to just go ahead and put in a couple more numbers, because if I plot the ones that I just got, let me do that first. If my pen will work, I'm having a very draggy, turn it off and back on. Delayed reactions. Oh, we don't want to be out there. Okay, there we go. -1, 0, 0, -1, and 1, 0. So that's not very much to go by. So let's say you decided, well, let's go put in some more numbers, but then I'm going to go the other direction. I'm going to put in integers. So I'm going to put in -2. And then I'm going to put in +2. See what I get. If I put in -2, -2 squared minus 1. Some of you would need to realize that sometimes it's better to do it in your head than use the calculator. If you don't type parentheses around this, you're going to get it wrong. What is -2 squared? Yes, and when you square a number, it's always positive, okay? So this is 4 minus 1, which is 3. And if you put in +2, you're going to get the same thing. 2 squared minus 1 would be 4 minus 1, which is 3. So -2, 3. 2, 3. Those are points on the, what's this thing called? When you draw, yes, it is a parabola. And I'm having trouble making it curvy like it should be. Oh well. There's my parabola for today. Alright, that is a parabola. We will do a whole unit on quadratics. You will find out there's more ways than you ever thought of to solve quadratics. Is this a function? Can you draw vertical lines anywhere and have it not only hit in one place? Yes, because even though my drawing isn't perfect, that thing keeps on getting wider, okay, as it goes up. So that is a function. What is the domain? Well, did I have any restrictions on what I could plug in? Could I put in 1,000,000 and square it? That's fine, I just couldn't plot it. Okay, but so there's no restrictions. So you actually could put in anything. You could put in decimals too. So you can go from -infinity to infinity on the domain. Remember, domain is what the values of x can be. Come here, pen. Alright, what's the range though? It's restricted. Now, we always want to do small to large, so I want you to go to low point upward. So its lowest point is at -1. It includes it. And then it goes up, 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 and away, so that's to infinity. This is the kind of thing you're going to have to be able to do on the quiz. You will have a graph of something like this, and you will have to tell whether it's a function, what the domain and range are. Now, for all of this x squareds, there's no restriction. So all of them are infinity, -infinity to +infinity. Okay? Is this 1-to-1? Can you do a horizontal line test? 1 second, Scott. No. So not one-to-one. Is it continuous or discrete? Can you square decimals and subtract 1? Can you? I didn't do it, but you can, right? So it's connected. Everything's connected. That makes it continuous. All right, next one. This is linear. How do I know right away it's linear? That's going to be a line. It should be in a familiar form to you. And x has a power of 1. You're going to learn about a whole bunch of different powers of x this here and how to graph them. This is a first degree polynomial or equation. It's in first degree. That's linear. So this is in slope-intercept form already, so we know the slope is 3 and the y-intercept is 2, so we'll start at 2 and then go up 1, 2, 3, right 1. 1, 2, 3, left 1, 1, 2, 3, left 1. Okay, and then we draw our line, try to hit the points. Missed a few. Put arrows on the ends and say, yes, it is a function because it passes the vertical line test. Is it one-to-one? Let's just jump right to that. Yes, it is because it passes the horizontal line test. The domain is anything you want can be put in for x, so it goes from negative infinity to infinity. Because that graph, if you kept extending the line, it will continue indefinitely wider and wider. And vertically, it's also negative infinity to infinity. And it's a connected graph, so it's continuous. Okay. Scott, did you still have a question? Okay, hit it. Okay. Because the range has just one number, one value. So you can't put it in interval notation because there is no interval. Does that make sense? Okay, so you just set notation. If it's discrete data and it's just dots, that's always going to be in brackets. You can't do discrete data in interval notation either. So that's a good question. Okay, so that was the end of that page. So now we're going to pop over to 14, please. Guess I could have just used this. We already did all this stuff, remember? I must have had, this is another year. I must have had to quiet people down or something. We already did all this. Okay, and then with my other class, I actually, we just finished that one, right? Okay. Oh, was there a question that says which of the graphs were, no, that's on here, never mind. 14AB. We're going to do a few together. I think that the first one, we've already done one so much like it that we'll skip over that one. Sound good? Because this is just stuff you're going to practice. All right, so 5x squared. This is going to be a parabola. Just 5x, what will it be? A line. Okay, so it would start at 0, 0, go up 5, right 1, down 5, left 1. But it's still, even though this thing is so, sorry, it's a really pretty miss. It is a function. It didn't ask if it's one-to-one, but it is. Its range is negative infinity to infinity, and so is its domain. And I should put brackets on those. So lines are pretty easy. Unless they're vertical or horizontal, okay, they're going to be This is going to be the answers to all lines that are oblique, which means they slant. If they're vertical, then we don't have a function. If they're horizontal, they're not one-to-one. On a parabola, this is a quadratic, x squared. That's how we know we're going to get a parabola. So number 3 is also a parabola. I'm going to leave that number 2 to you, and I'm going to go over here to number 3 because we calculate this wrong. Negative 5 times, we're going to plug in negative 1 and square it, plus 2. Again, I will have students who will type negative 5 times negative 1 squared plus 2, and they'll get 7. And it's wrong. Recognize that this thing should be one of these, a U-graph, okay? If that's not what you get, then check your calculations. Why is this not 7? What's so funny? Go ahead, type it in your calculator. I'm telling you, because if you're not practicing at all, you can mess this up. And even the best students mess this up sometimes. Good job. But do you understand that if somebody types this in the calculator and they don't put the parentheses in, they're going to get it wrong? That's all I'm worried about. Try it. It might. Now, if you don't, okay, I wonder if maybe this would be okay because of one thing about this particular problem, because of the negative 5. See, kids will type it like this. And there's no parentheses around this. And then it was plus what? And I get 7. This is exactly what I just said. Okay, if you put the parentheses in, you're going to get it right. The problem is you're not telling it to square a negative 1. Okay? So my point is, if you're going to type this in, you're going to have to put this around it. Because negative 1 squared is positive 1, and negative 5 times 1 is negative 5. Negative 5 plus 3 is 3. This should come out to be 3. Negative 3. And it is. There's the difference, okay? I'm just trying to make you aware of what you got to type. Yes? Yes, you can. If you've learned that, yes, you can. I wasn't going there yet, but yes, you can. Okay, so she brought it up. We'll go there. Nobody said anything to me the other hour. I would like you to know how to do it without it. Not everybody's going to have a graphing calculator necessarily at home sometimes because somebody can't maybe afford to have one at home, but you can do this without, you can, all right, you know what, I'm going to tell you what she's talking about. You might already know. If you go to y equals, and you put it in the equation, negative 5, it was x squared plus 2. And then she's saying you can go to the table. Second table. And you can see the values. And you can scroll it too. So here it is, negative 1, negative 3, 0, 2, 1, negative 3. Still lost? Don't worry about you. Just plug them in here now. You're going to have to fill this in. Now, you want me to say where I went just then? I just went to y equals, and I typed in the equation. Okay, if you hit graph, oops, I don't know why I just hit the clear button. Now, there will be some graphs that are going to be very difficult to see on here. I'm in a different mode. Hold on. Whenever your calculator doesn't do what you want, try hitting zoom 6. calculator stuck? I don't know, this thing's frozen. Well, anyway, it wasn't what I wanted to do anyway, so I'm going to drop it for now and plot these points. -1, -3, 0, 2. What happens when you plug in 1? You should get -3. So what happens with that negative in front of the x squared is it flips the parabola upside down. And we'll be talking about that stuff a lot this year. It is a function. Its domain is still -infinity to infinity, but it maxes out at 2. But wait a minute, we don't start with the largest, we start with the smallest number. So we go from down here, -infinity, up to 2, and we include the 2. Are you okay right now about just doing it by hand here? Okay. I don't want to teach the calculator today, okay? So I'd rather just ignore that. All right, there's, again, this is going to be a line. This one's going to be a U. This one's going to be a line. All right, so we want to practice that. You will have a couple questions like this on the quiz, where you're going to graph it, and then you're going to answer those questions. I wanted to do this one with you, because it's different. We should know that 7's going to be a parabola, a U. Okay, but it's going to open which way? Yep, yeah, because that negative sign, that one's going to open that way. This one's a cubic. Cubics do this or this. So let's see what it does. If you put in -2, -2 to the third plus 2. Now, why am I not worrying about parentheses? Any ideas? Scott? Okay, that's a good thought, but it's not really why it won't matter. That's not you. Would help go the right one. I gotta learn. I still gotta pass those quizzes back, and I don't. All right, Nathan. Order of operations. Okay. No, it's because. All right, Haley. Yep. It's because it's to the third. Odd power, you're gonna get a negative anyway. Yeah, that's why. Oh, that was good. Good. Good tries and just some thoughts. So what happens when it's a fourth power? You better parentheses. At even powers make it a negative. When you square or fourth power or 6, it's going to be positive. All right, so you have to use the parentheses. Yeah, I can talk. All right, this is -8 plus 2, which would be -6. If you put in -1, you're going to get -1 plus 2, which is 1. If you put in 0, you're going to get 2. If you put in 1, you're going to get 3. 1 cubed is 1, and 1 plus 2 is 3. And if you put in 2, you're going to get 8 plus 2, which is 10. You definitely would be nice for you to memorize that 2 cubed is 8. Okay, 1 cubed is 1. Know those, then you don't have to worry about the calculator. So then I'm going to plot these. -2, -6. -1, 1. 0, 2. 1, 3, and 2, 10. So here's what happens. The graph goes up like this, and then it makes a twist right here. And then it goes up, up and away. This is a function. Even though it does get wider, guys, as it goes. Okay, it doesn't. This is going to have a domain of -infinity to infinity. You can cube whatever you want there. And the range is going to be, oh, look, it keeps going, right? So it's coming down from negative infinity up to positive infinity. It's also negative infinity to infinity. Okay, do you think you could graph? I don't think, we aren't going to have a cubic on the quiz, but parabola, yes. I don't think there's a cubic. Okay, here's a very important part for us to go over today, so make sure you get this kind of question right tomorrow. It's the back of the worksheet on 14B. I'm going to do a few examples on here. Find the domain and the range for each graph. Are they functions? Are they one-to-one? This graph is continuous even though it doesn't have arrows because it's all connected. Now, what is the domain though? The domain is what x values can it have? What values of x are represented in this picture? So you find out the leftmost point and you say that's at -6 and it includes it. Now we do this because it's continuous, it will be a interval notation answer. Then it goes all the way over until boom, 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 here. And that's at +6. Good so far? All right, range, vertical values. So I go to the lowest point in the graph, which would be here at -3. I only draw that line over so you can see where I'm getting the -3 from. The lowest point here is at -6, -3. The part I'm looking at is the y part. And now I'm going to look at the highest point, which is here at 0, 4. The highest point is 0, 4, so the range goes from -3 up to 4. And there's something wrong with my answer. What did I do wrong here? I have to put a hard bracket. Yep, I have a soft bracket, and I should have a hard bracket. And I need it on both ends. Is this a function? Yes, but if I ask you if it's one-to-one, no. Anybody have a question about why it's not one-to-one? All right. This one is a line segment. Well, I think you can do that one. Practice that one. Let's go to something that looks hard. Can you pick one out for me? Maybe it looks confusing. Think you'd be good with 4 because it's just like a parabola? Ooh. Yeah, and my picture I found out is different for some reason than yours. It's the same graph except mine's moved. Yeah, isn't mine moved over? Yours is moved over right and up, I think. Yeah, it's not the same one. Okay, so please everybody look at 7 so we can agree on some numbers. In my key book, it's not this one, it's the one you have in front of you. I do not know what happened here. Something I probably should fix, but I can get around it. So when I looked at it in your book, I mean, in the same worksheet as you have, it looks like my x goes over to almost to -7. Would you agree with that? Yeah. Everybody looking, because yours is actually here. Right? It does that. And I don't remember where. Oh, wait. Your little hump right here is over there, isn't it? Yeah. You're just doing more like this or something. Okay? Anyway. Point being, it's at almost to -7. It's about let's just say -6.5. And then at the right, it keeps going, doesn't it? Is there an arrow? Yeah, so that keeps on going. So it's going to go out to infinity on the right. All right, then we'll talk about the range. The range of this thing, and I'm not going to call this a function because you see this part right here? You can mush into it more than once. So this is not a function. The range, though, what's the lowest place? Would be that dot that's there? No, it's actually the hump. And the hump comes down on your picture to about almost -5. All right, so -4.9, I don't care. Or -4.8, I just made something up. And then it keeps going up, so it's going to go to infinity. Obviously, if it's that ambiguous, I'm going to take a little bit of leeway on the decimal. Yes. Is number 6 a function? Where is number 6? Why is my what happened to my number 6 page? Well, poo. I must have deleted it on accident. All right, so I'll tell you. Is number 6 a function? Yep. Yes. It does pass the horizontal and the vertical, so it's 1-to-1 also. Do you see why it's a function or no? Oh, a curve's okay. Curves are still functions. It doesn't, oh, you thought, it's not flat anywhere. So it's 1-to-1. It's not like you see how that other one did that? It kind of went back on itself. That's why we said no to the last one, because it went back like that. We're not going to make them so they're really tricky. Scott? On number 3? Okay. This is an ellipse. You don't need to know that. You're confused because of where it's landing. So you're not confused about the concept that the x's are that's your domain from there to there on that number line? Is that what you needed to talk about? Okay, so is that about, it's not quite -5? I don't know. And then go up to 7. Looks like it hits 7, and that's a hard bracket too. So what's it doing vertically? It's going down to -2 and up to +2. And it's not a function. Circles are not functions. Or ovals. Yes, this is. Okay. I got a short amount of time left, I think. Yes. Okay, I want to pass back quizzes so you can see the last quiz. I want to tell you what we'll do tomorrow. You should practice your worksheet 16. You do need to do page 64, but I'm not doing the homework check till next week. I just want you to get this quiz out of the way because we're actually going to go further with the concepts here. The homework is probably harder than what's on the quiz. So I didn't want to make you responsible for page 64 when I haven't had a chance to answer any questions on it. Okay, so it doesn't have to be turned in tomorrow. I'm going to wait again. Homework check next week. We're still going to do our quiz too because we've covered everything you need for that. Remember that retakes are available. We still have like over 9 minutes. It's not time to go or anything. You can still be ready to ask me a question or anything, but I'm going to go ahead and try to pass these quizzes out and then see what else I can do with you. You start looking at page 16, I think. See if there's something on there you'd like me to look at, please. So 16 is the quiz preview, guys. Worksheet 16. Worksheet 15 is an outline of page 64. It's got all the graphs on it for you, so you do your page 64 in the book. You can work it out on 15, but then there's more questions that you'll have to do on your own paper. Okay, so I'm going to turn off my recorder for now.